Assalamualaikum and hello. My name is Izzudin, and today I will be demonstrating experiment entitled photovoltaic system. Alright, so in this experiment we have two objectives here. The first one is to determine the IV characteristic of two solar modules connected in series. And then the second one is to determine the efficiency of the motor. Okay. So in this experiment, we have a set of apparatus here. The first one is support brass, and then we have halogen spotlight, and then we have two solar modules, and then we have jumper wires, and then we have geared motor with the pulley, and we have weight holder. And then we have the terminal board with resistor cascade. And then we have two digital multimeters here. And then we have digital stopwatch, a set of scales, and finally power adjuster. So now that you know the apparatus, let's start the experiment. So the first objective is to obtain the IV characteristic of the two solar modules connected in series. Okay. So before we start an experiment, make sure that the support braces are in the vertical position. Okay? If it's not in vertical position, we need to unscrew this carefully and adjust the vertical braces until it is in vertical position like this. And then make sure the halogen spotlight is parallel to the solar modules here. Okay. And then we connect the digital multimeters here, so that one of them becomes voltmeter and the other is connected as ammeter here. We have two switches here. We set the first switch as series and second switch as internal. Okay. And then we adjust the power until it is at maximum like this. So now you are ready to take the readings of the voltage. So now let's take the current and voltage reading. Okay? But first we need to look at the appendix here. So in here we have four columns. We are given the load resistance here, or RL, and then we need to measure the voltage and current. And then finally we need to calculate its power here. Alright. So what do we do here? Okay. So we need to adjust the two knobs at the resistor cascade here. Okay. So now both of the knobs are showing 0 here. It means that the resistance is 0. Zero resistance here means the circuit is in short circuit state. And in short circuit state, the voltage is 0, but the current is not 0. Okay. In this case, the short circuit current here is read as 80.3 milliampere. Okay. If the reading is unstable, you can press the hold button and then you can take the reading here. So here we have two knobs here. The first knob represents 20 ohm, while the second knob represents 200 ohm. If we turn the first knob to 5 like this, okay, so we have 5 times 20, which is 100 ohm. So at the first knob, the resistance is now 100 ohm. Okay. At the second knob, if we turn to 1 here, okay, so we have 1 times 200, which is 200 ohm here. Okay. So the total resistance here is 100 plus 200, which equals to 300. You will need to take the reading for current and voltage from 0 ohm to 2000 ohm. As for the final row in the appendix, okay, it doesn't show any resistance here. What you need to do instead here is to disconnect one jumper from the ammeter, okay, like this. Okay. And then it is now in open circuit state. In the open circuit state, the current reading is 0, but the voltage reading is not 0. In this case, the open circuit voltage here is 19.3 volt right now. Okay, so that concludes our first objective. Our second objective here is to determine the efficiency of motor in energy conversion. Okay, Before that, let's look at our appendix here. Okay. So in our appendix, we have two tables. The first table here is the no-load power, while the second table is for the efficiency of motor in energy conversion. Okay. So both procedures look the same except for the calculation. But for the no-load power, there should be no weight on this motor. As for efficiency, there should be weight here. Okay. So before we do this experiment, make sure that the power is at maximum and there is no obstruction on the solar panel. Okay. So we set the first switch as parallel, okay, and then the second switch as external. If you do so, the motor will start moving. Okay. So now the motor is moving with no load power. Okay. So at the no load power here, we can directly take the reading for voltage and current here. Okay. So the no load voltage is 9.4 volt, while the no load current is about 13.9 milliampere. If the reading is unstable, we can press the hold button. Okay? Don't forget to press the release button before taking another reading. So we can calculate the no load power using equation 9 here, where P0 equals to I0 times V0. Alright. So we can set the second switch as internal again, so that the motor doesn't move. Okay? So what do we do here now is we unwind this thread here until it is about 60 centimeters long, or until it is sufficiently long as the weight holder here doesn't touch the floor. Okay? So what we do here is we take any weight here, let's say 50 gram, and hook it here like this, so that it hangs on the motor like this. Okay. So now what we do here is we want to turn this on, and to turn this on we set the second switch as external. Okay. So when we set the second switch as external, we need to take the reading for the 5 revolution of this motor. Okay. So we shall start now. Okay. Take the reference and start now. Okay. Here's the first revolution. Okay, so we have just taken the reading for the 5 revolutions, and our reading here is about 17.53 seconds. Okay, at the same time, I have also pressed the hold button here during its rotation here. So the current reading was 15.5 milliampere, and the voltage reading was 9.4 volt. Okay. Let's look at the appendix again. Alright, so in the appendix, we just take the reading for load voltage and load current. We can calculate the electrical power using equation 10. Okay. And then we just take the reading for the time taken for 5 revolution, which was 17.53 seconds. Okay. We can calculate mechanical power by using equation 11. And then finally, we can calculate the efficiency using equation 12. Alright, so that is for the first weight here. You will need to repeat the procedure for the other weights here. So you can take the other 2 weights and hang it here and repeat the procedure. And that is all for experiment entitled Photovoltaic System. My name is Izzudin, and thank you for watching this video. Goodbye.